Welcome to the Software Report, a leading information source on software companies and solutions. Today, we speak with Rochan Sankar, co-founder and CEO of Enfabrica, a company developing foundational networking technologies for the age of AI and accelerated computing. Enfabrica's hardware-software co-design approach enables modern data centers to connect GPUs, CPUs, and memory more efficiently, supporting the scale and performance required for today's AI workloads. Rochan is a 25-year veteran of the semiconductor and networking industry. Before founding Enfabrica, he led Broadcom's data center Ethernet switching business, where he was responsible for bringing multiple generations of Tomahawk and Trident chips to market, technologies that became widely adopted across cloud infrastructure. Today, he guides Enfabrica's strategy to deliver the I/O fabrics that underpin next-generation AI systems. I'm your host, RJ Lumba. We hope you enjoyed the show. If you liked the episode, click to follow. Rochan, thank you so much for taking the time to chat with us today. It's a delight to be with you.
Thank you so much for having us.
So I'm very curious to hear about the start of Enfabrica. You have a long, rich background in hardware and software, and you were previously at Broadcom for several years in very senior position. So maybe if you could take us back several years to the founding of Enfabrica.
Sure. I've been in the semiconductor industry for over 25 years, and building chips has been a passion of mine, and building big chips, primarily for data communications, networking, which eventually evolved into like data center infrastructure. And I got a great experience doing that at Broadcom over the course of nearly a decade. During that time, I actually collaborated with my now co-founder, Shrajit, who was at Cumulus Networks. And together, we had worked together from different companies on the silicon and the software architecture, products, solutions that actually ended up enabling the era of like open cloud networking. And so that was a great experience to be part of, got to, proliferate our products with very large customers, basically the cloud giants at that time. Around 2019, 2020, what was clear was the fact that, networking in the data center had primarily been oriented and built for traditional computing workloads, like, big data, large databases, the kind of things that Cloud 1.0, as I like to call it, serviced as workloads. Towards the end of that 2010s decade, you really started to see accelerated computing start to take off. And GPUs started to be deployed very prominently in the data center. At this time, it was mostly like recommendation engines. That was the big thing, a few years back. Companies like Meta, then Facebook, and Google had started building, generations of its TPU, its tensor processing unit. So you're starting to see the shift in the nature of compute. And networking, in the data center has always been sort of like a stitching of the compute together. And so when the compute was changing, and we could see that it could change even more dramatically in this direction of accelerated computing, how's the networking going to change? How should it change? And Shrajit was at Google at the time, and I was out of Broadcom and working on this problem. And we sort of came together and identified that, the traditional components like NICs and switches and PCIe bridges that we would find in traditional computing really would merit and benefit from a refactoring to really build a more optimal component for moving data effectively between the compute elements. And that was really the start of Enfabrica back in 2020. We had a few slides of PowerPoint, talked to a lot of people and our first investors. It happened to be COVID that just started in March of 2020. So that was an interesting time to be raising money. And we eventually, found the right partners from the venture community to help us get started. And then we were off and running by the summer of 2020. And we still didn't have a product at that point, but it was an exciting time to be trying to foresee what could happen over the next few years. And then come 2022, 23, when the ChatGPT moment happened, sort of validation that, hey, the primary focus of data centers going forward is AI and accelerated computing. And they require networking solutions that are very much addressed by the technology we've built here.
I'm always curious when we speak with founders who come together from this kind of corporate background, we have kind of two ends of the spectrum. Sometimes it's folks that start their first venture in college and they're always an entrepreneur. And then there's the folks that become more seasoned, become experts in a certain domain. I'm curious how you found the switch from corporate to starting your own company. Was it what you anticipated? Was it harder? How were you received in the market? So curious about that,
Yeah.
what you were going through at that time.
There is a wide spectrum of how companies can be formed and founded in, the overall tech space. But I believe in the semiconductor space, which is a more hardware manufacturing centric, very product centric business. It's very hard to do that, coming out of college, right? Or just having a few years experience. There are exceptions. I mean, I think Jensen founded NVIDIA like just after 2 jobs in the tech industry at in his early 30s. So there are definitely exceptions. But I think that in this day and age, you have to have absorbed the very broad and deep technical foundation and the foundation of what it takes to build product. Because what I can say is that it's extremely difficult to kind of put together all the pieces that you need to do that. You get to learn along the way because it doesn't happen overnight. But it's very different from, let's say, a software company or a pure like B2B or enterprise SaaS type of company where it's possible to have, sort of a whiz kid or a genius sort of young founder or set of founders be able to zone in on product and product market fit and then multiply based on network effect and the like. Semiconductors are generally a little bit slower in terms of its quote unquote network effects. And you have to get so many things right. Like you have to get product strategy right. You have to make the right investment decisions because the time it takes from your decisions for there to be the first validation that your product actually does something of meaningful value to a customer is so long. So many things have to be part of that. It's not just about, integrating the team. It's design discipline, verification discipline, how you test it, how you write software to it. All those pieces really come together. So I feel like the corporate world in semiconductors actually is a good teaching ground if you've been involved with very dynamic markets and very significant products, right? If you've been involved in the design, validation, and you understand what failed, what worked, that really helped a lot in being involved in that for a couple of decades prior to Enfabrica.
For the benefit of our audience, so we can better understand the solutions, products you provide, can you tell us a little bit about your market and maybe your client set? And if you were to categorize the clients that you have in that set, how would you kind of explain your broad set of clients?
Sure. Well, Enfabrica's mission is to deliver revolutionary networking silicon for AI and accelerated computing. When we say revolutionary, what we're doing is we are refactoring how NICs, switches, PCIe bridges, connections to memory, connections to storage, how those all get implemented, get architected and implemented inside or connected to an accelerated computing system. And so we have a chip. We built a chip that is the highest throughput networking device that attaches to any accelerated computing server. And it's called the Accelerated Compute Fabric SuperNIC, or ACFS. The chip's code name is Millennium. That's our internal code name. It's got 3.2 terabits of I/O bandwidth facing the network, 5 terabits of bandwidth facing the system, so a total of over 8 terabits per second. It is 4 times the throughput of the next best available networking silicon that is paired with today's GPUs. Okay. So just from that standpoint, we've built a chip that is a much bigger, wider, faster distributor of data to all of the components of an accelerated computing system, which, you can basically say, when I say accelerated computing system, I basically mean GPU server, for which big foundational models, AI services, hyperclouds are deploying hundreds of thousands of these GPU servers to support large language model processing, both training and inference, to support physical AI, and then to support digital twins, to support recommenders. So really, we're still at the nascent point of how pervasive AI compute is going to be in the data centers, of the future. And our product is positioned as the networking element that can attach to every single one of those. We've recently launched a very special system collaborating with some partners that actually, for the first time, attaches that powerful networking silicon to a very large array of memory, just memory. So if you think of a traditional server, you've got compute elements like a CPU or a GPU. Then you've got memory that's maybe attached to that CPU or inside the GPU in what they call HBM. And you've got storage and the like, but those are kind of the components that you see inside of an accelerated computing server. Traditionally, memory has never been separated from the compute processor, right? You've always had memory like sitting right there, right? Think of your laptop, like you always buy DRAM or you choose the option to populate your DRAM on your laptop CPU or the like. What we've done is we've actually disaggregated the memory from the GPU server and built an appliance that connects way more memory with commodity DDR using this very fast networking chip.
Mm-hmm.
And as a result, a whole cluster of accelerated computing servers or GPU servers can now do things like LLM inference at scale by constructing effectively a tiered model of how they move data between this large shared pool of memory that we have in our appliance and the local memory and the local compute that's in the GPU server.
Mm-hmm.
We've delivered a solution, we call it Emphasis, Elastic Memory Fabric System, that can be deployed at these very large scale data centers and AI compute farms in order to just drive better efficiency and drive lower cost per token per user. And that's, we think, a super important value proposition going forward in order to drive down the cost of AI compute for users and make it more pervasive.
As you're explaining your chips, your products, and functionality, I'm trying to infer how capital intensive this is because it's not just software. There's this hardware element to it, which is critical. I mean, I guess this goes to your investors too. Like, how do you estimate how much capital is needed to appropriately and effectively fund your company?
Well, that's where being part of an organization that built chips for, a living really helps. Like you get an idea and I manage products, some of the most successful networking products, still today in the industry back at Broadcom. And it gives you a good understanding of what the costs and team scales and the capital expenditures and the OpEx that's required to go build chips. And even then, your best estimate is probably not enough, right? But it is a very capital intensive undertaking. Chip developments routinely cost multiple hundreds of millions of dollars from inception to production deployment. And that's because it spans a long period of time. And there's a lot of expensive design and manufacturing processes involved in getting that done. When you combine that between design automation tools, emulators, the cost to tape out a chip, the cost to ship and push wafers through, get those assembled, shipped, tested, all your test equipment. So it's a very capital intensive undertaking. Fundamentally, I think when you're talking to investors about a business plan like this, you have to demonstrate pretty solid knowledge and awareness of all the things that are involved in that product cycle, to sort of get to where product market fit is in your rearview mirror.
Mm-hmm.
And I think that's key. Ideas last in terms of, a little bit of time in the early part of a company, but then execution and execution discipline is absolutely essential in order to actually build a hardware-centric company. I would say that we are equal parts hardware and software, to be honest with you, but fundamentally our product is a piece of hardware on top of which some very capable, complex software is running. So it's the combination of the two. So when you have to do both, it's actually twice the effort to try and figure out all the things that you have to fund and how you have to build your team to be capable of delivering that.
You explain this combination, and it's probably hard to find someone who has this type of experience, other founders that could enter this market. I imagine it's competitive, but maybe there aren't as many competitors as there traditionally would be in, say, a pure software subsector. Can you tell us a little bit about the market you operate in? Are there direct competitors?
Well, I think it's a survival game, to be honest. If you draw a point in time and then you sort of extend that timeline, there's a lot of hurdles to clear. And so, I think that there are, and I would encourage that there are many people who have, the creativity and the motivation and the acumen to start companies in the semiconductor space. I think that for a period of maybe like a decade and a half, we had a dearth of semiconductor startups because there wasn't really enough of a supporting ecosystem amongst investors and in the industry at large to really encourage that risk taking. And I think the industry suffered because of that. Consumers may have suffered because of that. So if innovation can only be left to the very big companies that have scale, you will get more and more incrementalism, right? Unless companies take of their own volition those types of risks. So I think that competition and density of semiconductor startups or silicon or hardware startups that we've seen in the last, I'd say 5, 6, 7 years has actually been great. In our particular space, I would say that the number of survivors up to the point in time that you get to product and the like, it really goes down because you had to have basically raised and then successfully spent and executed, a few $100 million at least funding to get to that point and prove it with customers like. And by the way, we're still in that journey, right? Like we're by no means like done on that. We just have a great product and an opportunity that we are capitalizing on right now. But I would say that while Enfabrica doesn't have, we think, competitors from the startup world that have this type of solution as networking for AI close to the server, that there could be ones in the future. And there's certainly ones in other adjacent hardware categories like switching or optics. And in compute, challengers to the existing GPU vendors like NVIDIA and AMD. So there are startups in that space. I think time will tell whether those companies can also clear those hurdles, get to product market fit in arrears, and find the ability to really scale.
We're coming up on time. Rochan, I have 2 final questions. One is, can you tell us about a person who has had a profound influence on you?
Yeah, I absolutely can. So in my case, it would be my dad. My dad was an engineer for his entire life. He was an academic and was a professor of mechanical engineering. He moved to Canada. I'm actually originally from Canada. I moved to the States in the late 90s, but he moved from India to Canada in the early 60s to do his PhD. So when we think of today's, like, lots of immigrants who come to North America to do their, graduate school, he was probably one of the first waves of those types of people to really do that. He was an engineer through and through. He's a professor, but he taught me so much about what it means to design product and to focus on a problem that has wide impact and applicability. And, just keep building on the things that you can create in that space and deliver value. He passed away in 2022, unfortunately, a little bit too early, but, a lot of the lessons that he imparted to me as a kid all the way to my adulthood, even when I was a grown man working in the private sector, he would still have lots of advice for me on what I was doing with my career or, what type of problems I was trying to solve. And I think all of us in the industry, we do things for reasons of ambition, but we are fundamentally formed by our parents and what the values our parents impart on us, or those who are our loved ones. And, there's definitely a part of what led to the creation of Enfabrica and where we are now that I can give credit to the lessons my dad imparted to me.
Excellent. Last question. Can you tell us about a charity cause or other endeavor that you're passionate about?
Yeah. Science and technology education, I think, is definitely, especially living in Silicon Valley, very well supported overall. But I think that a lot of it has moved to the practical sciences, like computer science, engineering, a lot of applied mechanisms there. And we, as a family, as individuals, very interested in supporting the pure sciences and pure mathematics as well, and encouraging that through our engagement and support for faculties of, the pure sciences, physics, mathematics, and the like. And so we encourage our children and our community to do that. It's definitely something that I feel will help solve the problems of the next generation when we start from the basics and try to figure out from first principles how to solve that. And I think it's important as we move through revolutions, industrial revolution to the digital revolution to the AI revolution, that education doesn't lose sight of the core sciences that led to all of this.
Wonderful. Well, Rochan, I want to thank you again for taking the time to chat with us today. It's been a great conversation.
Thank you very much.